It's going to wrap up the lesson on solving equations, systems of equations with matrices. So we have this problem that a game show host says that he has $5,000 in $50 and $100 bills. So in his pocket, he's got $5,000, and you know it's a combination of 50s and 100s. He'll give you the $5,000 if you can tell him what type of each bill he has. And his hint is that he has 73 bills total. So if he just literally counted the number of pieces of paper money that he has in his pocket, it would be 73. So we are going to use matrices to solve this. So first thing, we know that we have two different variables. We have the number of 50s and the number of 100s. So I am going to let x be the number of 50s and the y be the number of 100. So first of all, I know that there's literally 73 bills. So if I take the number of 50s and the number of 100s, just literally how many there are, that would equal 73. And the next thing I know is the value of that. Well, every single $50 bill is obviously worth $50. So if I take 50 times the number of bills, like if there was 2 of them, that would be $100. If there was 3, that'd be $150. So if I take 50 times the number of 50s plus 100 times the number of hundreds, I know that that is going to add up to that total of 5,000. So now what we do is we set up our matrices. So first we make the coefficient matrix. So that would be, and make sure it goes x and then y, so make sure it's lined up, which it is. So it'll go 1, 1, because those are the numbers in front of the x and y, and then 50, 100. And then that would have to be multiplied by the variable matrix x, y. And I know that is the order, because if I multiply, it would be 1x plus 1y, and then 50x and 100y. So that makes that one on the left. And that's going to equal 73 times 5,000. And like we discussed in the previous video, you're not able to divide by this matrix on the left. So in order to get rid of that, we're going to multiply both sides by its inverse. And the order of this matters. So I am going to multiply the left side by the inverse of that matrix. So I'm just showing my work here a little bit more thoroughly. And since the order of matrix multiplication matters, since I put the inverse on the left side on the left, I need to take the inverse of that matrix on the left side over here. So it needs to be the inverse of that matrix, then times that constant matrix. So the order over here on the right-hand side matters. Now, on the left-hand side, when I multiply a matrix by its inverse, it's kind of like multiplying 1 times a fifth, or I'm sorry, 5 times a fifth. If I take 5 times a fifth, those are inverses of each other, I just get 1. So here, what I end up with is the identity matrix, which is basically the matrix form of a 1. So on the left side, I just get xy. But on the right side, I need to actually put this into my calculator. Since we do not know how to do inverse of matrices by hand, there is a way to do that, but we are not learning that this year. So you just go alpha zoom, and I need a 2 by 2 first, and that's going to be 1, 1, 50, 100. And I need to multiply the inverse of that, so make sure you put that little -1, and then alpha zoom again. This is going to be a 2 by 1. And that would be 73 and then 5,000. Hit enter, and I get 4627. So what that means is that for the $50 bills, there are 46 of them, and for the $100 bills, there are 27. And that makes sense. If we add those together, you can see that that does total 73. And if I take 50 times 46, plus 100 times 27, that's going to give me that total of $5,000. Okay, last question. You can solve systems of equations with 2 or 3 or 4 or 5 or 1,000 variables, but you need one equation for each variable. So in this case, I see an x and a y, and I also see a z. So since I have 3 equations, I need 3, or I'm sorry, since I have 3 variables, I need 3 equations. If I had 8 variables, I would need 8 equations. But the nice thing about matrix math is once you set it up, it does all the work for you. So you don't have to do tons of substitution or anything like that. The only problem is that we do need it set up. So it goes x, y, z equals that constant number. So I just need to reorganize these and do that fairly carefully because that's usually the place where we make mistakes. So this first one, I want to keep the x on the left side, but then I need to bring the 4y over, so it's going to be minus 4y. There are no z's, so I'm just going to put a 0 there, and that equals negative 11. Then the next one, I have negative 3x. Again, I'm going to put that placeholder of no y's to make sure that everything stays lined up. And then I have 4 z's, and that equals negative 7. And then here, I need to bring the negative 5x over, so that'd be positive 5x plus 1y, just so I see that coefficient. I also need to subtract the 2z to get it to the other side. And that's going to equal my constant of 25. So now, in order to solve this, I need to make my matrix. So it's going to be 1, negative 4, 0. I'm just writing down the coefficients. That would be multiplied by x, y, z in that order. And that will equal the coefficient, or I'm sorry, the constants on the other side. Okay, so once again, I'm going to multiply by the inverse of this matrix on both sides, on the left side of both sides. And when I multiply the inverse to this one, that'll cancel it out and I'll end up with just x, y, z. But now I need to multiply this inverse on the other side as well. So again, I will let my calculator do that math for me. I'm simply indicating that I'm going to take the inverse of that times the constant matrix. So once again, I just grab my calculator and we do alpha zoom. And this time I need a 3 by 3. And then I type it in, so 1, negative 4, 0, and then negative 3, 0, 4, and then 5, 1, negative 2. And remember, you have to take the inverse of that, so don't forget the little negative 1 because you're taking the inverse of that matrix times the constant matrix, which is a 3 by 1. So negative 11, and then negative 7, and then 25. Hit enter, and the answer is 542. So that means that x, y, z is equal to 542. So obviously x is 5, y is 4, z is 2. We could quickly check that with perhaps this last example, this last equation, just to make sure that that makes sense. If I put the 4 here, I have negative 5 times 5 plus 2 times 2 plus 25. Well, if I add up the right side, that does add up to be 4. So that checks out. I could check the other equations as well, but given that that one works, I would assume the rest would be right as well.